Question 6. No calculator to be used. Simplify the final answer as far as possible. For students in the European schools, the probability of getting chemistry homework to complete for the next day, C, is independent of getting mother tongue language homework for the next day, L. Martin is in year group S4, where the probability of getting chemistry homework for the next day is 0.5 and the probability of getting language homework for the next day is 0.8. His brother Nathan is in year group S5, where the two probabilities are 0.7 and 0.9. Calculate the probability that both brothers will only have to do homework for one of these subjects for tomorrow. So we're going to separate those out and we're just going to draw a Venn diagram for S4 for Martin, and we have our two circles. We have chemistry and we have language, and we know that the chemistry is 0.5 within that circle and 0.8 within the language circle. Now we have this fact that if it's independent, we know that the probability of A intersection B is the probability of A multiplied by the probability of B on the formula sheet. So we know that the probability of chemistry homework for the next day intersection language homework for the next day is equal to the probability of chemistry homework times the probability of language homework. Obviously this is only if independent, but they are independent. So therefore that intersection is going to equal 0.5 times 0.8, which is 0.4. Half of 0.8 is 0.4. So we can write here 0.4. Looking on the left, if the whole chemistry circle is 0.5, that would have to be 0.1. If the whole language homework circle was 0.8, we would have 0.4. And 1, 2, 3, 4. What's missing is 0.1 to make up the probabilities adding up to 1. So we can already see that the probability of only one homework in S4 is going to be the 0.1 for just chemistry and a 0.4 for just language. So the two together, just one, is going to be 0.5. Okay, let's repeat that for S5. Same system. Chemistry and language. This is the S5. Our two values are 0.7 and 0.9. In the same way, the intersection is 0.7 times 0.9, 7, 9 to 63, 0.63. So we're going to have 0.63. A subtraction on the left, we're only left with 0.07. On the right, a subtraction, 0.27. When we add up those three, the missing number is 0.03. So, what's the probability of only one homework in S5? That is going to be the 0.07 and the 0.27, 0.34. Now, bringing everything together. So, if we think about S4, it could be both homeworks or one or neither. What are the numbers that we know? We just wrote it down. Both homeworks we saw above, 0.4. We have 0.5 for only one homework and 0.1 for neither. After that, we could have both one or neither after both for S4, both one or neither, both one or neither. This is for the S5. All we're interested in is a question that said both will only have to do homework for one. So we need one, and then followed by 1. Let's add the probabilities on the final branches of the tree diagram. We worked out that only 1 in S5 is 0.34. If we wanted to, we could put 0.63 and 0.03. So this is where we want our answer, 0.5 times 0.34, which gives us a half of 0.34. Final answer, 0.17. A 17% chance that both brothers will only have to do homework for one of the subjects